Advanced materials, from the largest structures to the smallest electronic components. Today, the need to make products faster, stronger, smaller and lighter has driven the development of materials with properties out of reach of previous generations. There's been a long history of materials evolving and changing how we as society interact with the products that use them. Things like Gore-Tex, Velcro, cement, even things like aluminium were classified as advanced materials in their days. And I think that what at the moment seems like space age, in 10, 15 years time will become an everyday application. Graphene is probably one of the most exciting advanced materials that we've looked at. Almost kind of like a miracle material. It's effectively carbon, it's a single layer of carbon. It's got properties that are sort of non-existent in other materials. It's stronger than steel. It's a better conductor than things like copper that are currently in semiconductors. It's a single atom thick, which makes it transparent. So when you think about that in terms of semiconductors on your touch phones and touch screens and all that kind of stuff, it allows it to be effectively transparent. I think one of the key areas where we can see graphene having a major impact on society is through water filtration, to really change the speed, the quality and the availability of fresh water throughout emerging markets. One of the areas where advanced materials is really focusing on at the moment is OLEDs. OLEDs are effectively the here and now of advanced materials, and so OLEDs stand for organic light emitting diodes, and they're effectively a display technology. What it is, it's an enhancement on current displays. So if you look at the history of things like televisions, they've gone from cathode ray tubes to LCD screens, plasmas, etc. And OLEDs are effectively the next generation on. Why they're so important is, firstly, it's the clarity and the vision and the colour that you get from the interface. So it's a real improvement on the user quality for things like TVs and smartphones. I think the other major application that's really going to come along with OLEDs is the flexible nature that they could enable. So at the moment, if you look at your phone or your TV, it's obviously a rigid and static piece of equipment. What OLEDs will enable ultimately smartphones to be able to do is you can fold your tablet into a smartphone. You could potentially fold your TV into a tablet. Another area is nanotechnology, and it's really focusing beyond the micro side of the equation that most people look at and going into the nano side of the equation, so it's basically just smaller. To put it into context into how small we're talking about, a hair follicle is 75,000 nanometers wide. I think one of the most exciting areas for nanotechnology could be in nanomedicine as an umbrella term to encompass this, is a better delivery of drugs into the body. So really allowing or creating a product that's bespoke for a specific issue. I think one area that's starting to increase is the potential for nanomedicine as a chemotherapy drug. So instead of having chemotherapy, which is very invasive, researchers are working at the moment, is there a way that you can use nanomedicine, nanoparticle to actually go straight in and tackle those cancerous cells rather than having to go through that chemotherapy process, which hopefully would have the same benefits but reduce the side effects that you get from chemotherapy. So advanced materials have the ability to change every facet of our life. We've focused on a few materials that we think are going to have significant here and now impact, but also some of them that are going to have a longer dated impact.